All right, day 2 of energy from the sun. We're on page 186. Electromagnetic waves. So on your piece of paper, electromagnetic waves in red as a heading on the left. Just what is light? Scientists took hundreds of years to discover the answer to this question. Light is not matter, but rather a type of electromagnetic radiation. Electromagnetic radiation is energy transferred by waves that can travel through empty space. Along with visible light, familiar types of electromagnetic radiation include radio waves, microwaves, and X-rays. Okay, so now on our paper, light equals E/M for electromagnetic radiation. Indent, waves, arrow, empty space, because the waves of light can move through empty space. Okay, examples: radio waves, microwaves, light. It's not in the book, but I added Wi-Fi, and X-rays. Each type has different properties that depend on wavelength. In the diagram below, wavelength is modeled by the distance between two peaks of the wave. Okay, so down here is wavelength. This has a very long wavelength because you can see it's a long distance between the peaks or a long distance between the valleys. As you move further to the right, they squish together more. The wavelength is shorter. It's a much shorter distance to go from peak to peak or valley to valley. Okay, so that's wavelength, how stretched out or how shrunk the wavelength is, the waves are. Radio waves have the longest wavelengths and carry the least energy. Okay, longest wavelengths, but least energy. In contrast, gamma rays have the shortest wavelengths and carry the most energy. So way out here you have gamma rays with the shortest wavelengths and the highest energy. In fact, gamma rays are so powerful they can penetrate most materials. To contain gamma rays, scientists use thick walls of lead or concrete. So right next to gamma rays is X-rays, which are also pretty powerful. So powerful that they can go through the skin and the flesh and your muscles. But they don't go through bones very easily. So that's why we use X-rays to take pictures of bones and your skeleton. It can get through all the fleshy bits, but it doesn't get through the bones, and you can see the difference. Okay? The sun emits waves across the entire electromagnetic spectrum, which is a continuous band that includes all types of electromagnetic radiation. So, the electromagnetic spectrum, and in these arrows we're going to draw an example of it. Okay? Scientists have developed technologies for both generating and using different types of electromagnetic waves. Radio and television stations transmit information by using radio waves. Microwave ovens use microwaves to heat food, and toasters use infrared waves to toast bread. Medical doctors use X-rays to look inside the human body. They may also use gamma rays to treat cancer and other diseases. Okay, so here's a model of the electromagnetic spectrum that we're going to draw. We're going to take all of this and shrink it down to that. In the middle, we want wavelength. On the right, we put short, and on the left, we put long. We draw a long wavelength example where it's all nice and spread out. We draw a short wavelength example where they're all squished together. Okay, underneath wavelength, we put energy. Way over here for the long, we put low. And over here on the right for the short, we put high. And then we put examples, and we put them in the same order. So radio is low energy, just like here. Microwave is next. Microwave. Infrared is right here. So capital I, capital R is infrared. We have light. That's all of the light that we can see, all the different colors. Capital U, capital V stands for ultraviolet. And then we have X-ray. Okay, next up, visible light. Visible light. Visible light makes up a very small part of the electromagnetic spectrum. So if we're looking at this whole long spectrum, just a tiny little bit right over here is the visible light. Visible light, also called white light, is a mixture of colors. In order from lower to higher energy, the colors are red, orange, yellow, green, blue, indigo, and violet. The colors form a continuous band called the visible spectrum. Okay, so visible light is a small part of E/M spectrum. It's a small part of the electromagnetic spectrum. A mix of colors, right? Mix of colors. Okay, next we put energy in the middle, high on the right side, low on the left side. And then I put each of the colors from the song that we learned way back in kindergarten. Red, orange, yellow, green, blue, but then we say violet. The reason I don't say purple is because past violet is the ultraviolet, or UV. Down here on the low end, past red is the infrared, or IR. So just like on this spectrum, you have all your visible light. Past the violet is the ultraviolet. That's the kind of energy that makes you get a sunburn if you stand out in the sun too long. On the low energy side, past the red is the infrared. That's the kind of energy that comes from things that glow hot, like a toaster or a hot heating element on your stove. Or like if you've ever seen pictures of like a thermal camera, or they say what does it look like to see through the eyes of a snake, where they're using thermal to see things. Or if you've ever seen the movie Predator. Okay, so we have the energy low and high. We have red, orange, yellow, green, blue, violet. All of those are visible, so I put visible, F-V-I-S-I-B-L-E, with an arrow. Past the red to the left is the infrared IR. Past the violet to the right is the ultraviolet UV. Okay, you can use a glass prism to separate white light into its component colors. Sunlight entering tiny water droplets in the air is also separated into colors. That is how a rainbow forms. Rainbows are common after a rainstorm or near a waterfall, but you can see rainbows even in mist from a garden hose. Okay, so prism/water splits colors, arrow, rainbow. A prism or water can split the colors into a rainbow. Most of the radiation from the sun that reaches Earth's surface is in the form of visible light. In addition, a small fraction reaches the surface as ultraviolet light and infrared light. Okay, so most sun radiation, arrow Earth, equals visible. Most of the sun's radiation that reaches the Earth is on the visible spectrum. What happens to other types of electromagnetic radiation? So just this tiny little chunk is the visible, and the infrared and ultraviolet's close to it. What about all this other stuff, the X-rays, the gamma rays, the microwaves, the radio waves? Where does it all go? Most are blocked by Earth's atmosphere, the blanket of air that surrounds Earth. As you will discover, the atmosphere interacts with solar radiation in a number of very important ways. So, atmosphere blocks other types. Atmosphere blocks, where's the word types? I saw it in here. Other types. Sequence. How does radiation change across the electromagnetic spectrum? So it's supposed to sound like a sequence of events, like a first, next, then last. Okay? Radiation changes across the EM spectrum from having a long wavelength with low energy to having short wavelengths with high energy. Okay, first come radio waves, next microwaves, then infrared light leading into the visible light that we can see, eventually ultraviolet light we cannot see, but it can cause sunburns, and ultimately into X-rays and gamma rays, which are so powerful that they can penetrate or go through some materials, like our skin or even wood and metal sometimes. All right, the electromagnetic spectrum. A radio receiver picks up and decodes radio waves to produce sound. Microwave ovens work because food absorbs microwaves. Very little heat is wasted. Inside a toaster, electrical energy is changed into thermal energy. Infrared waves toast the bread. Okay, so that would be like when you're standing in front of that little heating dish and it glows red and it makes you feel warm in the winter. It's doing the same thing inside of a toaster. White light can be separated into its individual colors by a glass prism or by raindrops. You can even see the different colors in here, right? Red, a little bit of orange, yellow. Can't quite see the green, but here's the blue. And then way out here on the end, it's very hard to see, but there's purple there. X-rays mostly pass through soft tissues, but are absorbed by bones. Doctors use them to take pictures of the body. Okay, that's it for this section. Good job persevering, and roar Wildcats.